Hello everyone, let's continue to talk about chapter 5, 5.1, section C. Okay, in section C, okay, let's do some recap for the past, from the last class. Okay, so section C will talk about equal vectors. So basically, there's two items we must understand. Okay, the first one we talk about the equal vectors. Okay, two items. Number one is two vectors are equal if they have the same magnitude and in the same direction. So two vectors are equal if they have the same magnitude and the same direction. Okay, so basically we call that is equal vector. Okay, then next one is also very important. So if vector 1, for example, is in the column vector form, so we write this x component, y component equals to x2, y2. So if this is the two vectors, then we will find out. Okay, we can have the answer is x1 equal to x2 and y1 equals to y2. Okay, so basically this is something we talk about equal vectors. Okay, the next concept we talk about is the negative vectors. Okay, negative vectors also have two items. The first one, for example, we have a line, okay, from A to B. Okay, we also have a line parallel, same lines, but in opposite direction. So CD. Okay, so from these two items, we can know A, B vector equals to the minus CD. Okay, because these two opposite direction. Okay, so we also from here we can see that this is called the negative vectors. Okay, negative vectors has the same magnitude but opposite direction. So this is called negative vectors. Okay, and then we also from here I draw a line. So from here we also know another concept. So if AB and CD are negative vectors, so we have this. So minus x, y equals to, we can move this vector in. Okay, so this is the same equation. So we understand these two important concepts, and we also learn about zero vectors. So basically zero vectors is the vector. Let's say for example from point A to A is equals to 0, then we have this in the column vector forms. So we have learned three very important concepts: 1, 2, 3 equal vectors, negative vectors, and zero vectors. This is what we learned from last lesson. So now we're going to continue to resolve some vector problems. Okay, let's look at the first one. Example 3. Okay, so in example 3, so we have they have given okay, let C equals to 3 and K. So if magnitude is equal to 5, so let's find the possible value of K. So we're going to find K. Okay, so let's draw a diagram for this. Okay, so basically, okay, after this we're going to draw. Okay, so how to resolve this problem? This problem. Okay, solution. So we know C magnitude is 5, so and C equals to 3K. So let's look at the formula. Okay, we use the formula. We know, okay, equals to, we know the C magnitude equals to the x squared plus the k squared. Okay, so from here we know it's equals to 5. And then we just make both sides square, so place 2 plus k2 and then 5 square, so it's come 25. 3 here, from here we know it's 9. 9 plus k2 and then move down here. Here both sides will minus 9. Minus 9, minus 9. So this is cancel, and from here is from 16, right? So then we have a 2 answer, plus minus 4. Okay, so basically K, so K can be equal to 4 or K equals to minus 4. Okay, so how to draw this vector in the Cartesian plane? Okay, let's assume this is Cartesian plane. So we have so this is the origin, this is the y-axis, this is y-axis, this is the x-axis. So from here we can see that, okay, so if let's say we put that in the cases k equal to 4, so we have 3 and 4. So let's find out. Let's find out where's the number 3 is here and 4 is here. So 3 is here. Now we can find out here, right? Right. So the other point, so let's connect these 2 points from origin to the coordinates. So in here we can draw a line going up. So the next one, so this is all minus, okay, because this thing. So same thing, we bring in minus 4, so it should be here. It should be somewhere about here. Okay, now let's draw this line. We join up these two, then we get these things. Okay, so basically this one is going up, right? And this one is going up. Okay. So this is the case is k equals minus 4, and then this case k is plus 4. Okay, so now we finish example 3. Let's move on to the next one. Now we move on to the next one. So we have next one is number 4. So basically we have A, B, C, D. So we have A, B, C, D is the parallelogram. A, B, C, D is a parallelogram. Is a parallelogram. Okay, so the first one is to explain whether AB equals to DC. Okay, this is the first one. The second one, explain whether BC equals to DA. Okay, so this is two questions. Okay, right? So we have these two questions. Okay, let's draw a parallelogram. So we have A, B, C, D. So we have A, B, C, D. Let's go count to the solution. So because the first one A, okay, since A, B, C, D is a parallelogram. So in this parallelogram, so AB is parallel to the DC. Okay, so this one. Okay, so from here we can see that is AB and DC are the same direction. And then we also know, okay, from the parallelograms is the opposite, two opposite. These two are equal. So from here we know AB in terms of length. AB equals to DC. So they have the same magnitude. Okay, so from here, so with the same direction, same magnitude, so here we can easily come up AB equals to DC, right? Okay, because they have the same direction, same magnitude. So now next look at B. We can apply the same concept. Okay, so basically we're talking about BC, from B to C, and then from D to A. Okay, this direction. So and then we can easily find out. Okay, so because in the parallelogram, so BC is parallel to the AD, right? Okay, but however, AD, because AD equals to minus DA, right? Because they are opposite, right? So in a sense, so hence, okay, but also we can find out this is this. So the two of them actually is equal. From the parallelogram, we can see that BC equals to AD. Okay, so they are the same magnitude. This one equals to this one because they are parallelogram, right? Okay, same magnitude. Okay. So from here we can see, okay. So basically from here we can see that is BC is not equal to DA, alright? But actually BC, because they are the same magnitude but opposite direction, so in the sense is we can find out is BC actually equals to the AD or minus DA, right? So we can work out in this. This is example 4. Okay. Now let's look at the next example. Next example 5. Okay, in example 5 we talk about two forces. Okay, two forces is operating. Okay, so basically the problem is, okay, let's draw a line. Okay, so basically assume this is the ground. So we are both acting on a particle. Let's say this is a ball. So one is about 40 degree. Okay, this is F1, and the other one is F2, downwards, right? So in a sense, it's okay. We also know this F1 is equals to 50 Newton, and the other one is 30 Newtons. 30 Newtons. Okay. So how to represent? So okay, we have one things. Okay, so basically F1 equals to 50 Newton, which is making an angle at 40 degree with the horizontal line. Okay, and then we have another one, F2 equals to 30. So which is at vertically down. Why is to the 40 degrees to the horizontal? Okay, so let's represent these two first as a vector in the program. So we represent this one as a one vector. One vector. Okay, so how to resolve this problem? Solution. Okay, let's look at this one. So basically, we can just make a simple drawing here. So this is the question drawing, right? So basically, let's do 9. Okay, let's assume we have let's assume this is the 1. This is 2. Okay, and this is 0. Okay. Then we have one direction. Let's say this is A, and the other one is the B. So this is F1, and this is F2, right? So that is angle here. So for 40 degree. Okay. So in a sense, so we can draw. So how to So we have these two atoms. So in a sense, okay, so represent. So what's the question? The question is represent those two firsts as a vector in diagram. Okay, so let's draw a diagram. Okay, so we assume 1 cm. So probably we can see here. Let's say we say okay. From here we see how much. Okay, in here we will write it this way. So 1, 2, 3, 4, 30. So that is this direction. Okay, that's a lot. Okay, we see. Okay, this one. This is actually this is 5 cm. 5 cm. So equals to 5 cm equals to 10 Newton. Okay, so we can draw a line. So assume this is the object. So this is horizontal level. This is horizontal level, and then we go up. So 50 is 5. 50 5 1 2. Okay, so 1 2 3 4 5. So this is A, first is F1. So here is 40 degree. Okay, the next one, first you go downwards at the 30, right? So it should be 3. 1, 2, 3. Okay, so from here, right? So from here we can represent. So in a sense, it's every 5 cm will be 10 Newton. So here got 1, 2, 3, 4, 5, so it's 50 Newton. And then here 1, 2, 3, 3, so it's 30 Newton. Okay, that's all for today's class. So, and then we also have some try it. So you can just go back and try. So basically we have a tree. So today we discussed tree, right? Let's go back and try it. Okay, once go back home, so please try another 3 examples. The first one is number 3, number 4, and number 5. Okay, thanks for watching. We stop here. Thank you very much. Bye bye.